So, good afternoon, everyone. And today I'm going to discuss about determinant, properties of determinant grammar school, and we will do some numericals on determinant. So, before that, do you have any doubts, any queries regarding the previous discussion or uh, today's discussion? Is there any doubts that you have regarding the previous discussion? That is, we have discussed about basis and linear independence and all those things. So if you have, you can ask. So I assume that you do not have any queries regarding the previous discussion. So I will start with today's topic, which is determinant. So you are all basically aware about that determinant things, that we can determine only the square matrices. So we can't determine rectangular matrices. So if the determinant comes out as 0, so that means that your matrix is not invertible. If determinant is unique, that means you will get, sorry, if determinant is non-zero, that means you will get a unique result. So determinant means you have a same number of your number of variables and number of equations both are same. If the number of variables and number of equations both are same, let's say you have a 3 variables and 3 equations, then there is a possibility that you will get either multiple solution or one solution. Uh, Let me go back to a previous discussion where you have this. Yeah. So here you can see that in case of square matrices, so that means the number of variables and number of equation both are same. So that means if the matrix is full rank means matrix is invertible. That means we will get unique solution, right? But if the case is like your matrix is square, but still the rank is not full. Rank is not full means we will never get all the pivots. Like each row does not have pivots. Like there must be one row or two rows does not have any pivots. That means those rows are zero rows. So in that case, matrix is not full rank. So in that case, we will get multiple solutions. That means our matrix is inverse of that matrix is not possible. We will never get an inverse of that matrix. So we see all those things from the point of view of Gauss elimination method. Now we will see all these kind of things from the point of view of determinant. Okay. So there is nothing much to discuss about determinant like theoretical. So I will start here with numericals and we will do everything accordingly. So the first start with a small question. So we have this kind of thing: 2, 5, 1 is equals to 2x 4 6x. So we have to find the value of x. Okay. So this equation that you have given, and you are asked basically to find the value of x. So this is basically a very simple question. So we know how to find out the determinant. So let's say I try to find out the determinant of this matrix. So how this determinant works? First multiply these two, okay, and then minus of multiplication of these two. So that means multiplication of 2 minus 20, and here we get minus 18. And the next is 2x 4 6x. So this is equal to what we get? 2x square minus 24, right? Now we have to equate these two equations, and what we will get? And this is 3, right? So x square is 3, so x is plus minus root 3. Okay, so in case of determinant, so we know there's a two distinct procedure to find out the determinant. So in if since this is a 2 cross 2 matrix, it's very easy to find out in this. So this is called a cofactors method. Okay, so this is called basically cofactors method. So what is cofactors method? We basically here. So here when we try to find out the determinant of this matrix, let's say I call this matrix as A. This is 2, 4, 5, 1. So when we try to find out the cofactor, means we try to find out the cofactor of this term. So cofactor of this term is 1, cofactor of this term is this, right? So sorry. So what we do, we try to find out the cofactor, and also along with the sign. So in that case, in case of 2 cross 2 matrix, the signs are something like that: plus, minus, minus, plus, in that procedure. Okay, means cofactors of 2 multiplied with 2, and then cofactors of 4 multiplied with cofactor of 4 is minus 5 multiplied with 4. So what we get? 2 minus 20, that is equals to minus 80. So this is how something like that. Now, in case of uh, just a minute. So in case of determinant, the signs are basically distributed in this fashion. So let's say if I call this matrix E, let's say I have a 3 cross 3 matrix. Okay. So how this sign is distributed, something like that. Let's say I have 1, 2, 3, not maybe 4, 5, 6, 7, 8, 9. Okay. So here you can see sign of all the diagonal elements are positive. Okay. The upper diagonal element here, these signs are negative. Okay. Just a minute. Did something wrong? These thing in that fashion is not better. I do it in this fashion. So this is something like plus, minus, plus, minus, plus, minus, and then plus, minus, plus. In this fashion, the all the cofactors. When we say that we have to do, we have to find out the cofactors matrix, because we know that when we try to find out the inverse of a matrix, the cofactors matrix is required, right? So when we find out the cofactors matrix, so this particular sign is actually required for that. Okay, so particular sign actually required for that. So when we try to find out the cofactor of 1, we have to incorporate the sign of cofactor, this cofactor of 1. So plus of this. So cofactor of 1 is, so cofactor of 1 is this determinant. Okay. Simi- Cofactor of 2 is, how to find out the cofactor of 2? So you have to, I mean, you have studied, must be you have studied in plus 2. So I just basically recall these things. So you just negate this row and this column. So you will find this all term. So cofactor of 2 is basically 4, 6 determinant with 4, 6, 7, 8. Right. Similarly, cofactor of 3 is, you have to negate this row and this column, you will get this determinant. Similarly, cofactor of 4, you have to negate this row and this column, you will get this 4 element. Okay. Similarly, 5, you have to get this 4 element. So 6 with just this term and this term, right? Similarly, 7, you have to negate this thing, you will get this term. Similarly, 8, you have to negate these things, you will get this fourth term. And similarly, 9, this fourth term. Okay. So these are the cofactors of each element. So when the value, when the matrix, the rows, number of rows and columns are increases, so it is quite difficult to find, difficult to calculate the determinant of a matrix using this cofactors method. Okay, why it is difficult? I mean, it is basically, the process is basically lengthy, because let's say when let's say I have a matrix A something, A11, A12, A13, A14, A15, 21, 31, 41, 51, 22, 32, 452, 23, 33, 43, 35, 45, and 5. So determinant of this matrix, what is the determinant of this matrix? So it's A11, then determinant is cofactor. A11, then determinant its cofactor, right? This term. I'm not writing down this term. Then minus, so it would be plus, minus, plus, minus, plus, right? Then minus of A12 determinant, you have to negate this row and this row and this column, and you will get other determinant, which is 4, number of elements. So in that way, you have to this, let's say again 1, 3, you will get some cofactors, then 1, 4, you will get some cofactors, and then 1, 5, you will get some cofactors. Now, since this is also a determinant of 4 cross 4 matrix, you have to find out the determinant of, again you have to find out the cofactor of A32. You have to find out the cofactor, since you will get this determinant. In that case, you have to find out the cofactor of this term. Then, so this will be the cofactors of this. In that case, you have to do all those things, right? Because ultimately you have to find out the determinant of this fourth term. So when we find this case of 5 cross 5 matrix, so in case of 5 cross 5 matrix, we have to do a multiple calculation, because we have to find out the determinant of 4 cross 4 matrix, we have to determine the 3 cross 3 matrix, and then we have to determine the 2 cross 2 matrix. And when we ultimately goes down to 2 cross 2 matrix, we do not need to do the 1 cross 1, because obviously in 2 cross 2 matrix, when a determinant of 2 cross 2 matrix is basically one small term you will get, right? So there's a multiple calculation is basically going on. Similarly, if the matrix is 10 cross 10, the calculation is very big. So in that case, or you can say what computers basically do to find out the determinant of a matrix is basically pivot method. Pivot method means, so what is pivot method? So pivot method says, so we say that if a matrix A, if a determinant of matrix A is non-zero, that means it has the rank of that matrix is full. That means it has all, this matrix has all pivots, right? So I'm assuming that whatever the matrix that I'm going to choose over here, let's say this matrix, I'm considering any 3 cross 3 matrix, okay? So whatever the matrix that I'm going to choose over here is a full rank matrix, okay? So let's say this is the matrix. So this is, let's say, full rank matrix, okay? So now you have to do an elimination method. So we have to reduce this matrix into a row echelon form. Okay, so let's say after performing Gauss elimination method, let's say the matrix that I get is something like that. The first is A1, A12, A13. This is 0. This is some element, let's say B22, some element I'm considering. You have to do the row operation. And this is something B23 and then 0, 0. And again, let's say this is C33. Okay. So this is the, so this is basically, you can see this is basically an upper triangular matrix. So in case of upper triangular, lower triangular, or diagonal matrix, the determinant of that matrix is basically the multiplication of all the diagonal elements, right? So that means, so if you, in case of lower triangular, upper triangular, and diagonal matrix, the determinant is the multiplication of all the diagonal elements. So that means in that case, the first what we have done. So here first we reduce this matrix into a row echelon form. Okay, by using a Gauss elimination method, and then we have to perform the determinant. So determinant is basically A11, B22, and C33. So this is very easy to calculate. Now, computer basically does this kind of thing. They choose to, they first reduce the matrix into a row echelon form and then multiply the diagonals. So it is very easy to performing all those things. Okay. Now, in case, so here basically considering that the matrix A is full rank. Now, if the similar matrix, if the matrix is not full rank, if matrix is not full rank, so what we will get after performing row echelon form? So definitely that means we lose. I mean, there must exist one row, at least there must exist at least one row which does not have any pivot. What does that mean? That means after performing, let's say after performing this row echelon method, after performing this Gauss elimination method, so what we will get, let's say A12, A11, A12, A13, 0, let's say, okay, 0, and this is B12 or B22, B23, and the last term is 0, right? Last term, because definitely the matrix is not full rank. That means the one row, there exists one row which does not have any pivot, right? So in that case, what will be the determinant of matrix? Obviously the same. The procedure is same. You have to multiply the diagonal element. And once you multiply this diagonal element, definitely the determinant comes out as a 0. So if you do the same thing by using the cofactors method, you will get that determinant of that matrix is 0. So by observing that, in case in this upper triangular matrix, by observing that since the one diagonal element is 0, so that means the matrix determinant is 0. So this is very easiest way to perform this whole determinant thing. Okay. For obviously 2 cross 2, 3 cross 3 is not a big issue, but it is issue for higher dimension system like 10 cos 10, 20 cos 20. In that case, you have, if you do all those cofactors method, then it will be difficult. I mean, the process is very cumbersome. I hope up to this point is okay to everyone. Now, the another property that you must have studied, you must have seen in the lecture videos as well. So another property of determinant, we know that, let's say we have equation number of we have uh, system of equation. Let's say I have this x a1 I a1 3 z equals to b1 b2 1 plus a b2, and then a3 1 a b2 1 a3 b3. Now we have if you follow the previous discussion where I have said that if you exchange the row, like instead of writing, now if you write down these things in a matrix vector format, what you will get? So let's say I call this is x y z, this is b1 b2 b3, and this is something a11 a12 a13 a21 a22 a23 a31 a32 a33, right? Now if you exchange a row or exchange a column, okay, so if I write down these things a11 a12 a13 a31 a32 a33 a21 a22 a23 x z y b1 b3 b2. Now if I say the find out the determinant of this matrix, so definitely the matrix is, I mean, the solution that you will get xyz, the value of xyz is definitely, there is no change in value of xyz, but since this is a matrix A and this is something like matrix, not exact matrix A, this is something like matrix A bar. So determinant of A and determinant of A bar, how they are related? They are related is determinant of A is basically minus of determinant of A bar. So in that way, they are basically related. So if we exchange a row, okay, if we exchange a row with another row, or if we exchange a column with another column, in both cases, there is a changes in the sign only, nothing more than that. Determinant is same. I mean, the magnitude of determinant is same, but there is a changes in the sign. You will never get the determinant of this exchanged version of matrix will become zero. No, this will never happen. Only the sign will change. Other than that, determinant is same. Similarly, the properties in case of properties of determinant, you will see that transpose of any matrix cannot change its determinant. So determinant of A, so determinant of A is basically determinant of A transpose. The transpose of a matrix does not change its determinant. Okay. So now I will do uh, okay. So the question is first question. So question says that prove that the determinant of this matrix A square AB AC BA minus B square BC and CA. So if you have any queries, any doubt, please stop me at any moment, okay, so that I can clear it out. BB minus C square. This equals to 4A square B square and C square. Okay. So this is a matrix that you are given, and question says the determinant of that matrix is basically 4A square B square and C square. Okay, so I'll start with this. So in general, determinant, I mean, in books or in lectures, you can see that the determinant basically showed by this Greek letter big delta. Okay, I mean, this is not a actual rule. You can use any letter for that, but normally shows this using this Greek letter. So in case of determinant, you can take common term from each row or from each column. This is the property of determinant. But in case of matrix, you can't do that. When we do some kind of matrix operation, let's say addition, multiplication, or that Gauss elimination method, whatever, when you do these kind of things, we cannot take a particular element, common element out of that matrix. It's not possible. In case of matrix, when we multiply any scalar, matrix multiplication, when we multiply any scalar with a matrix, that means that scalar multiplied with each and every element of that matrix. But in case of when we do the determinant, there is a property is like we can take a common element out from that particular row or particular column. So in that case, what I will do, I take particular from row 1, I take common A. Okay. So I'm doing the 3 operation consecutively in one step. So from row 1, I am taking out I'll just write down over here. Taking common row, common A from row 1. Similarly, B from row 2 and C from row 3. So I am taking common A from row 1, B from row 2, and C from row 3. So what I will get? I will get minus A, B, C. Okay. So sorry, it's A, B square, sorry, B, and then C, and here A, B, and minus C, right? So I take out this A, B, and C consecutively from row 1, row 2, row 3. Okay. Now, as I said before, you can take common an element from row or from column as well. Now, what we can see that in column 1, there is a one common element, that is A. So I can take out A from column 1, B from column 2, and C from column 3. Similarly, so what I will get, I take out A, B, and C. So from column 1, column 2, and column 3 respectively. So this is 1, 1, 1, 1 minus 1, 1, and this is 1, 1 minus. So what I will get is a square, B square, C square. So that means our what the question that I have to prove that this determinant, I have to prove that this determinant is equal to this. So I already get this a square, B square, C square term, right? Now I need to do the I need to find out the 4. So if you do the determinant of this matrix right now, because here all the elements are 1, so it will not be difficult to find out the determinant of this matrix. Sorry, it will not be difficult to find out the determinant of this matrix, but I will do something extra. I will do some row and column operations so that I have to do a little bit less amount of work. Okay. So I do the first column operation that I'm going to take is the first column operation that I'm going to take is basically I'm changing this column to how do I change this? I'm adding this column to it, column 1. What I will get, it's a minus 1, 1, 1. I'm not changing anything with the column 1. Column 2 is minus 1 plus 1. This is 0. Okay. Now this one is 0 and this one is 2. Now I am doing another operation similarly over here. So the next operation is I'm changing the column 3. And how do I change this column 3? Similarly, I am adding this column 3 with column 1. Okay. So column 3 is basically here 0, this is 2, and this is 0, right? So what we'll get? We get this kind of net. Yes.
Sir,
Yes.
also you can change the row 2 and row 3 with
I mean, you can do the row operation. Actually, I did here I do this column operation because we have not done any kind of column operation in matrix row elimination method. So I just want to show that you can do the column operation as well. That's why. I mean, you can do any row operation as well over here and do the same thing. Okay. It is up to you, like which operation makes your effort less to find out the determinant of the matrix. Okay. So in that case, what I have to do is nothing more than that. So I have this a square, b square, c square, and I have this minus 1 determinant with 0 to 2, 0. Because I do not need to write down 0 multiplied with this term and 0 multiplied with this term, because obviously ultimately whatever the term I will get, it is also multiplied with 0. So the term is basically 0. So I do not need to write all those things. Okay. So what I get, so a square, b square, c square, this is minus 1. So this is basically how this multiplication happened. First, these two multiply, then minus of these two multiply. Okay. So this is become 0 minus 4. So ultimately I get. So now you can say that LHS left hand side is equals to right hand side. So your proof is done, right? So I think this is clear to everyone. Okay, we will do a similar kind of uh, question for the next case. Yeah. So the next question is basically it says that similarly show that determinant of this matrix, that is 1 1 1 a b c and a square b square c square is basically b minus a, c minus a and c minus b minus a, c minus a and c minus b. Okay, right? So first thing is okay. So what we have to do now, let's say we can do over here is we can do the row operation. What will be the row operation? Let's say I'm changing this row 1. Okay. So row 1 is basically, let's say row 2 minus row 1. Okay. So row 2 minus row 1, I'm changing. So what I will get is 0. This is a minus b. This is a square minus b square. 1 b square, 1 c square. So now from here, from row 1, as I said before, you can take common one element from
sir,
here.
sir ଆପଣ row 1 changes to row 1 minus row 2 ହବ।
Oh, yeah, sorry. Yeah, that would be row 1 minus row 2. Yes. Sorry. Thank you. Thank you. So as I said before, you can take common from common and you can take common and common element from particular one row. So here I'm taking common a minus b. Okay, I'm taking common a minus b from first row. So this is as usual 0, this is 1, and this is what will be this? This is a plus b, because a square minus b square is basically a minus b, and a multiplied to a plus b. Okay, so b square 1 c square, right? So what term here I get is a minus b. I mean, obviously it's a b minus a, but let's see. So now I have to find out b minus c. I have to take common b minus c somehow, or c minus b somehow, and finally a minus c or c minus a. Okay. So what operation I have to do? The next operation that I will do is I need to change R2. How to change R2? R2 minus R3. If we do R2 minus R3, I will get b minus c. Then I can take b minus c common from the second row. So it's a 0, 1, a plus b. Now it's 0, b minus c, and this is b square minus c square. This is 1 c square, right? So here a minus b. Now I'm taking common a minus b and b minus c. I'm taking common b minus c from second row. So it is 0, 0, 1, 1, 1 c. Now a plus b, b plus c, and c square, right? Now in that case, now you can do the same determine because you get 001 format. So in that case, what you should do, how to do this uh, determinant, so that you have to do the less computation. So I'm not going to take this term multiplied with this, then this plus minus this term multiplied with this term. I'm not going to do that. I'm just taking this term. Okay. So if you see, there's a 001 kind of structure over here, right? So what you should do is A minus B, B minus C. Okay. Now this one, so if you take this element, so you have to negate these two things, this row and this column. So this is the cofactor of 0, right? Now, as I said, this is plus, minus, plus, minus, plus, minus, and plus, minus, plus. In this format, all the signs are distributed. So I'm taking only this column, taking as this column and find out the cofactor of the elements of this column. So cofactor of elements 0 is basically this, right? Now, since it is multiplied with 0, so I do not need to write that. Cofactor of this term is basically you have to do this kind of thing. So 1, so if you negate this column and this row, so you will get these two terms, right? This fourth term. So 1a plus b, c square. But this determinant is multiplied with 0, so I do not need to write that. And now what I do, I just need to write down this determinant, which is multiplied with 1. And its sign is basically positive, right? So 1 determinant with 1a plus b, 1b plus c, right? So what we'll get, a minus b, b minus c, and here what we get, it's b plus c minus a minus b. So you will get a minus b, b minus c, and c minus a. But what the question asks that it is b minus a, c minus a, and c minus b. So you just need to do that, taking common minus from here, b minus a, c minus a, and taking minus common from here, minus minus plus, you will get c minus b. So this is root, right? So this is our answer. That means LHS equals to RHS. So so you have to check that how you can reduce your computation, whether it is possible to find to do the column operation or to do the row operation, because how you have to find out the value. Now the next question, okay. Now the next question is, it's a short question. So if a matrix A is invertible matrix of order n cross n, of order n cross n, then determinant of A inverse is equal to, let's say, I'm giving you four option. I'm going to ask you what will be the answer. If you, let's say, how many of you can answer this. So what I asked over here is that matrix A is invertible. That means obviously the matrix is full rank matrix. Now that means A inverse exists. Okay, if matrix is not invertible matrix or it's not a full rank matrix, sometimes you may ask that if matrix is a full rank matrix instead of invertible matrix, you may ask that if matrix A is a full rank matrix of order n%, then what is the value of determinant of A inverse? Now, among these four options, which option is correct? Please, can anyone care to answer this question? So, if matrix is a full rank matrix, what will be the determinant of?
Third,
Uh,
sir.
sorry.
Third option. Third
Uh,
option.
yeah, that's right. So, third option is the correct option. That means determinant. So, how is this? How is this happening? So, we know that since matrix is invertible, that means we know that A inverse is equal to I, right? So there is another property that I'm going to use over here. Now I'm taking determinant on both sides. So determinant of A inverse is basically determinant of I. Now we know that I is basically identity matrix, right? I is identity matrix of order n, right? So order n. So that means what is the determinant of this matrix, identity matrix? As I said that for upper triangular, lower triangular, and diagonal matrix, we can find out the determinant of a matrix by multiplying all the diagonal elements. So if we multiply all the diagonal elements, we will get 1. So determinant of I is basically 1. So what we'll get, determinant of A inverse is basically 1, right? Now there is a property, another property of determinant, which is determinant of AB is equals to determinant of A multiplied with determinant of B. Now what we do is a determinant of A multiplied with determinant of A inverse, we will get 1. Okay. So since determinant is basically a scalar term, so determinant is basically a function which takes the matrix and we get the scalar format, right? Because we can't divide matrix. If we say, let's say a notebooks, maybe A is a matrix. Okay. So we can't write 1 by A. This is wrong approach. We cannot write 1 by A. There is nothing 1 by A exist. So in that case, what should we write? If matrix inverse is exist, we should write A inverse. This is the correct approach because we cannot get 1 by A. There is a nothing something like there is a nothing like 1 divided by matrix. This never happened because division there always exists a scalar term. There should exist a scalar term, but we can write 1 divided by determinant of A because A is a determinant of A is basically a scalar term, right? So 1 by matrix, any matrix is not a correct approach to write something. Okay. You may think that okay, A inverse is basically the power of matrix inverse something, but this is not something like that. A inverse is completely different matrix. Okay, which comes out from A. So in that case, determinant of A we can write. So that's why we get determinant of A inverse is basically determinant of 1 by determinant of A. So here determinant, I'm just writing down, that's a delta is basically a function, what this function does is basically taking the, I'm just considering the real number, it's not necessarily a real number, it could be a complex number as well, taking the matrix from real number, and where it maps to the n cross n, taking the n cross n matrices of real number and maps to the some real number. Sometimes it's like 1 into the power, sometimes just r. So this means the scalar term, and this means the matrix term. So this is basically the a function, something like. Okay. Next to another operation. Sorry, another numerical. So what is numerical says? Similarly, using the properties of determinant, prove that this following determinant is 1 x square x 1 x square and x square x1, this equals to 1 minus x cube to the power square over 2. So how we'll do that? We have to use the properties of determinant. Okay. So here you can see that one thing we can do that if we add all the columns, if we add all the columns to change particular column, then one thing common in that case, right? Let's say I'm going to change the column C1, and how I will change it? It's C1 plus C2 plus C3. So why I'm doing this? Because if we do this kind of operations, we will get 1 plus x square, which is basically a factor of 1 minus x cube, right? So if you do this kind of thing, so it's 1 plus x square. This is 1 plus x square. This is 1 plus x square. x1 x 1. So now I'm taking common from 1 plus x square. So it's 1 1 1 x1 x square x1, right? Now next, what I will do, I just want to change R2. How I will change R2? It's R2 minus R1. Okay. So if we do this, what we'll get? 1 x square, then 0. This is 1 minus x, and this is x minus x square, and here 1 x square 1. Okay. Now from here, what we can do, we can take common 1 minus x from second row, right? If we take common 1 minus x from second row, what left in that second row? 0, 1, and here only x. 1, x square, 1. Now again do the same thing. I want to change the row 3. How to change this row 3? So I will change this row 3 by row 3 minus row 1. So if we do these things, now this term, how can we write this term? This term is basically nothing but 1 minus x cube, right? So this is basically 1 minus x cube. This is 1x, x square. So here 0, 1, x, and here 0, x square minus x, and 1 minus x square, right? Now I'm taking common again 1 minus x from the row 3. I'm not writing down this common kind of thing. You can understand what I'm doing. So 1 minus x I'm taking common from here. So what I will get? X square, 0, 1, x, and then 0, here minus x, and here 1 plus x, right? So now if I do the if I do the find out the determinant, what I will get? So I just need to do this cofactor only, because if I choose this term, what left? 0x, 0x, x plus 1. So determinant is 0. If I choose this term, 0, 1, 0 minus x, determinant is 0, right? So I do not need to write these two things. I just need to write only 1, determinant with 1x minus x, 1 plus x. So this is 1 minus x cube. This is 1 minus x, and this is 1 plus x square. So this term is again 1 minus x cube, right? So 1 minus x cube into 1 minus x cube, we will get 1 minus x cube square. So that means hence LHS equals to RHS. Okay. So I think everyone understand. Now we do another example from here. So if you have vertices of a triangle, so you know how to find out the area using those vertices, right? So let's say you have vertices. So before that, let A, which is x1, y1, B, which is x2, y2, and C, which is x3, y3. These three are the vertices of a triangle. So A, B, and C are the vertices of a triangle. Then the area of the triangle is, so area of triangle, which is basically half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is basically the area of the triangle using the vertices, right? So how can we write these things in a determinant format? So if we say that this is basically, so this is basically a scalar term, right? So we can write it in a determinant format. So in determinant format, what can we write? So this is half because of this half, and then here x1, x2, x3, here y1, y2, y3, and here 1, 1, 1. So this is basically, so if you do this determinant, you will get that this kind of things that will, this kind of things you will get if you do this determinant process. Okay. So from here, I'm going to show you one example. So the question is, the vertices of a triangle are K0, 4, 0, and 0, 2. Okay. So the question is, find the value of K if the area of triangle is 4 square unit. So you are given basically the area of the triangle and the 3 vertices, but one of the vertices is basically a variable. So you have to find out that variable to solve this solution. So we know that area of a triangle is basically x1, x2, x3, y1, y2, y3, and this 1, 1, 1. So area of a triangle is basically given to you, which is 4, right? And this is also vertices are k 0, 1, then 4, 0, 1, then 0, 2, 1, right? So here we do not need that much row operation because almost pretty much there are 3 zeros in this element. So we do not need to do a row operation. I mean, you can do if it is required for you. So first k multiplied with 0, 1, 2, 1, and then minus. I do not need to multiply with 0 because ultimately this 0 term is multiplied with that determinant. So I'm just skipping this term. So then plus 1, 4, 0, 0, 2, right? So what we'll get is half minus 2k plus 8, right? So basically 8 equals to minus 2k plus 8. So what we'll get, k equals to basically 0. What is the value? What are the vertices? Vertices. So vertices are x1, y1 is basically 0, 0, x2, y2 basically 4, 0, and x3, y3. These two are already given 0, 2. So now here you can see, so this is basically the one answer. So this is basically the area of, I'm taking the area as a positive term. Obviously, area could be always be positive, but if possible that instead of 0, 0, so how this triangle, so how this triangle is basically, so this is one vertices 0, 0, then 4, 0. Let's say this is another vertices, and this is another vertex. So this is basically the triangle, right? So this is basically the triangle. So the area is basically 4 square unit. So it could be possible that there maybe these vertices, I mean there may be there may exist another vertices which makes another vertices along with this. I mean the value of k must be something else along with this 4, 0, along with this 4, 0 and 0 2 vertices will get a 4 square unit area. So in that case, what we will have to choose? We have to choose same thing, but this is taking a positive sign. Now I'm taking a negative sign. So if I take the negative sign, so what we will get? Minus 4 equals to half. This is 2k plus minus 2k plus 8, right? So what we'll get is minus 8 equals to minus 2k plus 8. So that means is k equals to minus 8. Somehow it is coming out as k equals to, sorry, k equals to plus 8. So if k is something like that, so something like if k is somewhere this 8 comma 0, and if we take this, if you take this area of if you find out the triangle, this triangle, area of this triangle, eventually we will get the same area. So that means the value of k could be, so this is either this term or x1 y1 equals to 8 0 and x2 y2, these all are same. I'm not going to write them. So that means either the value of k is 0 or value of k is 8. Okay, now we'll do, so now you have given a matrix A, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, and also you are given its inverse as well. So it's 1 by 4. This is 3 2 1 2 4 2 and 1 2 3. Okay, now the question asked us find the cofactor matrix, find the cofactor matrix and call it as a C. Okay, This is the first question. Second question asked is basically multiply A with C transpose and compare AC transpose with A inverse. Okay. So I have this matrix and okay. So I have this matrix. Okay. Now I have to find out the cofactor of this matrix, right? So cofactor, how this cofactor matrix we can write? So first we have to find out the cofactor of 2. So what is cofactor of 2? This is determinant of 2 minus 1 minus 1 2. So this is positive sign. Okay. Now cofactor of minus 1. What is cofactor of minus 1? You just have eliminate this row and this column and you will get minus sign with minus 1 minus 1 0 2. Now cofactor of 0, what is cofactor of 0? It's minus 1 2 0 minus 1. This is positive sign. Okay. Now again cofactor of, I have to find out the cofactor of this term minus 1. So I have to neglect this row and this column. So what I will get? This is negative sign. It's minus 1 0 minus 1 2. So this middle term is positive. So I have to negate this and this. So it is 2 0 0 2. And then I have to find out the cofactor of this term. So it's basically again negative sign 2 minus 1 0 minus 1. You just also check that whether I'm doing something wrong or not. Okay, because this is basically a big matrix. I mean, now cofactor of 0. Okay, so cofactor of 0 is basically this is a positive. We have to take minus 1 0 2 minus 1, then negative cofactor of minus 1, which is cofactor of minus 1. So it's 2 0 minus 1 minus 1, and then again the last term is positive, is 2 minus 1 minus 1 2. So now I have to find out the cofactor. So this is 4 minus 1, that is 3. This is minus 2 and 0, minus 2 minus 0. So this is minus 2 minus minus plus plus 2, and this is plus 1, right? Now this term is again minus 2 minus minus plus 2. This is 4 and this is minus 2 plus 2. Okay, so this term is 1, this term is 2, and this term is 4 minus 3. Okay, I think I get the right answer. Now I have to multiply. The first question has been solved, that is find out the cofactor matrix C. So this is the cofactor matrix. Okay. Now I have to multiply this cofactor matrix with A. So what is so A? First of all, I have to take a transpose of this C transpose. So I have performed this operation. So I have to transpose this operation 0 minus 1 to minus 1. This is symmetric matrix, I guess. 0 minus 1 2. Yeah. Now I have to take a transpose of this C transpose. 3 2 1 2 4 2 and 1 2 3. C is basically you can see it's basically symmetric matrix. So this is x minus 2, this is 4, this is 4 minus 4 0, this is 2 minus 2 0. So this is minus 3 plus 4 minus 1 0 minus 2 plus 8 minus 2. This is 4 and this is minus 1 plus 4 minus 3. This is 0 0 minus 2 plus 2 0 0 minus 4 plus 4 0 0 minus 2 plus 6 4. So this is AC transpose, right? Now A inverse that is given to us is basically 3 2 1 2 4 2 and 1 2 3. So now it says that compare AC transpose with A inverse. So A inverse, as you can see, is a 4 C or C transpose, as you can see. This is basically because here C and C transpose both are same. So that's why you can't say that this is you can't you can expect this is a C transpose. And what is AC transpose? AC transpose is basically 4 into an identity matrix. So now if you do the determinant of matrix A, so what is matrix A? It's 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. So if you do the determinant of this matrix, so you will get so it's a 2 4 minus 1 plus 1 is minus 2. So this will be 6 minus 2, that is 4, right? So AC transpose is basically determinant of A into identity matrix, right? So you can here you can say that A inverse is basically C transpose divided by determinant of A, right? Because which is 1 by 4 C transpose. Now if you remember the definition of A inverse, which is adjoint of A by determinant of A, right? And what is adjoint of A? Adjoint of A, adjoint of A is basically transpose of cofactor matrix. So that means, so this is basically the definition of A inverse. Okay. So now we will do the Cramer's rule, Cramer's procedure. So Cramer's rule only applicable if the system has unique solution. Okay. That means if the system does not have a unique solution, we cannot get a Cramer's rule. So unique solution means that matrix has to be a full rank. Since here we are basically dealing with only square matrices, so obviously either you will get unique solution or multiple solution. Zero solution only exists if you do not after after doing the row elimination method, if you cannot get 0 equals to 0 format, then only no solution exists. Okay. So yeah, I have the equation and I need to find out the solution of these systems of equation by using Cramer's rule. So I hope you are all aware of this Cramer's rule. I'm not going to describe what is this Cramer's rule, but doing this procedure, doing this numerical, you will get to know eventually how this works. 2x 2y plus 3z equals to 1 minus 3x minus 3y minus 2z equals to 4, then minus x plus y minus 4z equals to 2. Now find the solution using Cramer's rule. So if you write down this is in a matrix vector format, so what we will get 2 minus 3 minus 1, 2 minus 3, 1, and 3 minus 2, 4, x, y, z, 1, 4, 2, right? So first we have to find out the determinant of this matrix and we have to check whether this matrix is a full rank matrix or not. That means whether its determinant is non-zero or not. Okay. Here I'm not going to do any kind of row operation because since it's a 3 cross 3 matrix and numbers are pretty much like 2, 3, and 1, so it is very easy. It is very easy to find out without doing any row operation. So this is minus 3 minus 2, 1 minus 4, then minus 3 minus 2 minus 1 minus 4, and it's minus 3 minus 3 minus 1 1. Okay, so what we'll get, it's a 2, it's a so 2 multiplied with 12 minus 12 plus 2, which is 14. Okay, now 2 here multiplied with 12 minus 2, that is 10, and here 3 multiplied with minus 3 minus 3 means minus 6. So this is 28 minus 20, that is 8. 8 minus 18, that is minus 10. So that means your determinant is not equals to 0. That means we can get the unique solution. We can get the value of x, y, and z, right? Now, in Cramer's rule, what it said, we have to make another matrix A1, where the first element sorry, first column, where the first column is basically replaced by this vector. Okay. So 1, 4, 2, then 2 minus 3, 1, and then 3 minus 2, 4. Now determinant of A1, what is this? Is 1 minus 3, this minus 2, 4 minus 2, 2, 4, and 3, 4 minus 3, 2, 1. So eventually it comes out as a 68. Okay. Now, since we have three variables, so we have to do this kind of operation three times. Means the first case, what we have done, we have basically replaced the first column with a b vector. Next, we have to replace the only second column with a b vector, and third, we have to replace only the third column with a b vector. So similarly, what we get A2 is basically the A matrix is same, but with a replaced the second column, the replace second column. Okay, and we have to find out this A2, so which is this comes out as a minus 40. Okay, now I have to do the same operation and replace the third column only. So this is A matrix. First and second column will be intact. In the second case, first and third column is intact. Just exchange the replace the here replace the third column. 1, 4, 2. Now determinant of A3 is minus 3, 4, 1, 2, minus 3, 4, minus 1, 2, minus 3, minus 3, minus 1, 1. So it comes out as minus 2, 2, 22. So now what is the value of x? So x is basically determinant of A1 by determinant of A. Y is determinant of A2 by determinant of A. And z equals to determinant of A3 by determinant of A. So from first case, what we'll get is a 68, right? So 68 divided by minus 10, which is minus 6.8. Here similarly, minus 40 divided by minus 10 is 4. And here minus 22 divided by minus 10, which is minus 2.2. So now, if you check, so 2 minus 3 minus 1, 2 minus 3, 1, and it's 3, 2, 4, multiply with minus 6.84 minus 2.2. So you will get
The value of G is positive.
sorry, yeah. So it's 13.6 minus 13.6 plus 8 minus 6.6. So it's in that case 3 minus 20.4 minus 12 plus 4.4, and it's minus, sorry, plus 6.8 plus 4 plus 6.8 plus 4 plus 8.8. No, it should something. This is minus. Yeah, minus 8.8. So this thing comes out as 1. This thing comes out as 16 minus. Did I do the right thing? Sorry, this one should be plus. Yeah. So this comes out as it is too close. Minus. Oh, this is minus 2, right? Yeah, this is minus 2. My mistake. This, this is minus 2. So since this is minus 2, this one should be minus. So it is 16 minus 4, and this is minus 2 plus 2. So that means this is the value of x, y, and z, right? So now in this discussion first week, we have done one thing. We have done our question, this question. Now we have seen this question using row elimination method. Now we will do the same thing using determinant approach. So I just copy this example. So the question asks that a boy walking along the path through the particular 3 points. So he wants to meet his friend at point 7, 60. Will he meet his friend or not? So path is basically something like ax square plus bx plus c, right? So this is basically the path. So we have said, I mean, the question already mentioned that that boy passes through this particular 3 points. So for the first point, let's say that P1 is minus 6, 8, P2 is minus 2, minus 12, and P3 is 3, 8. So from here, we get the three equation. If we put the value of y and x over here, we get the three equation. The three equations are, it's a 36a minus 6b plus c, which is equals to 8. Okay. Then 9a plus 3b plus c equals to 8, and 4a minus 2b plus c equals to minus 12, right? So using the Cramer's rule, I will try to find out the value of this ABC, because once we find out the value of ABC, we know the basically the curve. Basically, in curve, only ABC, these three coefficients are unknown to us. We have to find out the curve, and we have to check that this final point is basically exact the point where is it the exact point where he will meet his friend or not. So what is the matrix? Is 36, 9, 4, minus 6, 3, 2, and 1, 1, 1. Okay. So try to find out the determinant of this matrix. So before that, let's say I'm not going to use the cofactor method to find out a determinant. I'm using the pivot method that basically computer does. Okay. So what pivot method basically does is it exchanges its row. I mean, eliminates something. That means I want to change row 2 in this fashion, right? And row 3 in this fashion, right? So after that, what I will get? So if we multiply row 1 by 4 and then subtract it from row 2, so it is become 9. So this is 0. So this term is basically 6 by 9. So 6 by 9 means minus 2 by 3. So 3 plus 2 by 3, which is, sorry, 6 by 4. Sorry, 6 by 4. It's 3 by 2. 3 by 2. So 3 plus 3 by 2 is something 3 plus 3 by 2. Yeah. So it is basically 9 by 2. And this is 1 by 4. 1 minus 1 by 4. It is 3 by 4. And here it is 0. This is minus 2 by 3. 2 plus 2 by 3. Right? 2 plus 6 by 9 is 2 by 3. Yeah. 2 plus 2 by 3. There is something wrong with that. Just a minute. 1 by 9. 6 by 9 means 2 by 3. 2 plus 2 by 3 is 8 by 3. Right? And then 1 by 9. 8 by 9. Sorry. This is minus 2.
Sir,
Yeah. Yes. Yes.
in row 3 in the second position, so the minus 4 by 3.
That is, I forget to give a sign of minus, I mean, sign of 2, and that is the negative sign. So it will be minus 2 plus 2 by 3, that will be minus 4 by 3. So again, now I want to change the row 3. How to change the row 3? So it's a row 3 plus 8 by 27, row 2. So if we do multiply 9 by 2 with 8 by 27, we will get 4 by 3. Right? So it is 36, 0, 0, minus 6, 9 by 2, 0, 1, 3 by 4, and this is 8 by 27. So 2 by 9 plus 8 by 9 is a 10 by 9. So it's a 10 by 9. Now what would be the determinant of A? Is 36, 9 by 2, 10 by 9. So it is 180, right? So determinant is comes out at 180. Now what you will do, you have to do the Cramer's rule. According to the Cramer's method, you just replace this B vector at the first column, and the second and third columns are intact. Find out the determinant of that A1 matrix, let's say, and the determinant of A1 divided by determinant of A, you will get the value of A, small a, right? So if you see, if you do this thing, if you replace this B vector at the first column, you will get some A1 matrix, and the determinant of A1, you will see that comes out as 180 as well. So that means the small value, small a, basically comes out as 1. So you will get this answer. So once you get this answer, you just do this, as a homework, you can do it. So if you do this, you just find, using the Cramer's rule, you just find out the value of a, small b, and small c. So now you know the exact equation of that path that the boy basically tried to follow. Now this is the final point. Now put that final point over here. If you put that, I mean, x value, you will, if you get that y value, that means this is basically the final point that satisfy this equation. That means boy, if the boy follow this particular curvature, then he can meet his friend. Okay, so you can, I think already I have done this solution in the first discussion, so you can check and do this accordingly. Okay, using grammar. I hope it is fine for you. So this is for today's discussion. So here I'm ending this discussion, and till now, if you have any kind of query, you can ask me. I'm happy to answer all the questions. Otherwise, I will wrap this discussion, stop this recording, and we'll meet the next week. Okay. So if you do you have any query?
No, sir.
Okay, then I'm just stop my recording, and you will get this. You will get this recording through. I mean, I will definitely share this recording and this presentation with you. You can check it over there. Thank you. Bye.
Thank you, sir.
Thank you.